Okay, this is the algebraic fractions example 4. So allow me to remind you, when we have a multiplied by b, that is one term. When we have a divided by b, that is one term. And if it's written as a over b, it's also one term. Okay, so if you look at what we have on the left here, we have a single fraction, which is one term, multiplied by another single fraction, which is one term. And that multiplication should remind us that this entire lengthy fraction is in fact still one term, and so we will apply our acronym when solving this, and that is to factorize, cancel, and simplify. Okay, another thing I want to bring to your attention is that a fraction like this, a minus b over b minus a, is a monomial and can be simplified, right? It should be simplified using our facts rule, but when you look at the sum, it appears that it's impossible for us to do that, but it is not. We have a tool in our pocket which is called the sign changing rule from last year in grade 9, and so we can rewrite this as a minus b over a minus b with a negative sign out front, because we still end up with negative a, which we had over here, and positive b, which we had over there, right? And now that we did the sign changing rule, we can simplify this, right? A minus b is equal to something, and then we have that same something in our denominator, and so they cancel, which leaves us with minus 1 simplified. Okay, so just keep that in mind as we approach the next example. So of course we need to factorize, so we look at the numerator of the first term. I see a common factor, so I'm left with x squared minus x minus 2. I see another common factor in the denominator, so I got x and x squared minus 1 multiplied by 1 minus x all over 2 minus x squared. Now this denominator is already factorized, and so there's no need to go and mess around with that one. Okay, we can factorize this numerator even further, and so we go 2. We can see that it's a trinomial, and we want to get minus 1, so we're going to go x minus 2 and x plus 1. And then in my denominator, I have a difference of 2 squares in the bracket, so I go x plus 1 and x minus 1. Now in this fraction here, I'm hoping that you can see that the x plus 1s will cancel, right? And then in my denominator, I have x minus 1, right? But I don't have another x minus 1, but I can if I go ahead and take this one and use the sign changing rule and make it x minus 1 instead of 1 minus x. So I do the sign changing rule over there so that I'm able to eventually cancel out the x minus 1. Okay, then in this denominator we have the 2 minus x squared, so I'm going to write it out twice just so that we can see where it cancels out. Okay, and then perhaps you can see on the top right of this fraction, we can take that x minus 2 and make it a 2 minus x so that it can cancel out. So I'm going to change this to 2 minus x, but I cannot forget to change the sign on the outside of that bracket. And so now we get to a point where we can cancel top with bottom, so this will cancel with that. Okay, the x plus 1 will cancel with the x plus 1, and the 2 minus x will cancel with the 2 minus x. Okay, and so now in green I'm going to circle everything that is remaining. So what remains is that we have this minus 1, we have x, and we have the 2 minus x. Okay, and so our final answer will be Negative 2 multiplied by negative 1, which is positive 2 all over x, and 2 minus x. And so that over there is our final and simplified answer for this fraction after we applied our facts for fracts. So let's just go back. When we got to this step, we sort of manipulated the sum so that we could cancel as many terms as possible. So again, in yellow, I did the sign changing rule over here. Okay, I did the sign changing rule, and I also did the sign changing rule over there. Okay, so that was necessary for me to get this expression in a form where I can cancel as many terms as possible.